Good afternoon, students. Today we shall be looking at a topic in chemistry, but before we do that, we'll just quickly have a recap on what we did in our last class. In our last class, we talked about hydrogen peroxide being the second major hydride of oxygen besides water. And in addition to that, we also looked at the laboratory preparation of hydrogen peroxide as well as its industrial preparation. Furthermore, we looked at the physical properties of hydrogen peroxide and the chemical properties of hydrogen peroxide. Now, and most importantly, under the chemical properties of hydrogen peroxide, we saw that hydrogen peroxide performs a dual function in reactions as either an oxidizing agent or a reducing agent. So in today's class, we shall be looking at the topic ozone. And so let's move. Okay, if we look at ozone, let's look at a few highlights on ozone. First, ozone is an unstable triatomic molecule of oxygen. Ozone is an allotrope of oxygen as well, and its chemical formula is written as O3. Now, ozone exists in a layer of height of about 20 to 25 kilometers above the Earth's surface. Now, ozone is formed from atmospheric oxygen by lightning flashes. Now, there are also other methods of forming the ozone. The following methods are the reaction of nitrogen oxides and hydrocarbons in sunlight, that is your ultraviolet light. Then we have bypassing streams of oxygen through a silent electric discharge. Then we can also have electric spark of car engines and electrical appliances in trace amounts, where of course ozone is produced in smaller quantities than by lightning flashes as a large quantity. Now the next that we are going to look at is going to be the preparation of ozone. Okay, ozone is prepared from oxygen with the use of a silent electric discharge. I beg your pardon. Now, the equipment that we use in producing ozone is known as the ozonizer. I have the sketch already on the board, and the name there is ozonizer. Now, how does this equipment work? What happens is that, first, on this equipment, there's a thin layer on top of it, and you can also have a thin layer. You can also see that there's a thin layer in the inner part of the diagrams. Those thin layers that we have, both on the outer part and the inner part, is what we call the tin foils. The tin foils. They are responsible for the conduction of electricity. Now, these other equipments we have are known as concentric glass tubes. Okay, now the foil are connected to a source known as the induction coil. It's just a sketch of the ozonizer. So what happens is, on one part of the ozonizer, you have an inlet where dry oxygen is passed through. So we have the dry oxygen. And once that process starts taking place in the inner tube of that equipment, the products we are going to have are going to be ozone and oxygen as well. So if we look at the equation of the reaction, the equation of reaction simply tells us we have 3 molecules of that oxygen, which is actually converted to 2 molecules of ozone. They are both in their gaseous state. So next, let's look at the physical properties of ozone. So number one of its physical properties is that it is a pale blue gas at standard temperature and pressure. Number 2, it has a pungent smell. That is, it does not smell nice. Number 3, it is a poisonous gas at concentrations above 100 parts per million. However, there are some other school of thoughts that says its own poisonous state is at 120 parts per million. But so we can have the range of 100 to 120 parts per million. Number 4, pure ozone can be obtained as a blue liquid from ozonized oxygen at a temperature of minus 112 degrees Celsius. Then the last one, it is slightly soluble in water, but it dissolves in turpentine. Turpentine is an organic solvent. And so next, let's look at the chemical properties of ozone.